Hello, today I'm going to be demonstrating how to CAD like a really basic gearbox like this one. So first we have to determine what our gear ratio is going to be, and that's determined by our driving gear, which is the one that is spun by the motor, to the driven gear, which is the one that is being spun. So here we're setting our driving gear, the one being spun by the motor, to 12 teeth, and it's a 20 dp gear. And then the driven gear is a 64 tooth gear. So and that gives us a ratio of a 5.3, and it's a 5.3 reduction because we have a smaller gear going to our bigger gear, which means we're gonna get more torque, but it'll slow the speed. So first, we do our part studio. So first we create our sketch of the plates. So for our first plate, it's going to be the one that holds the gear and the motor. So it'll need a bearing hole for the thunder hex that the gear goes on, and then mounting holes for the motor. So first thing we're going to do is we're going to create our motor here. Sorry, I forgot to mention this before, but the reason why some of the sketches were like dotted lines instead of full lines were because those were construction sketches. So for that, you would the keyboard shortcut is Q, and a construction sketch basically means it's like not like actually there. It can't be extruded, but it can still, you can still use it. You can still use it to like constrain other stuff. So like if you created a circle over here, you could still set it equal to, like you can still dimension it and then like set things equal to it or whatever. But like you could never extrude the construction sketch. Like that. Okay. And we're going to use a Kraken X60, so the diameter is 60 millimeters. And then we're going to create our two gears. So the way you CAD a gear is basically the size is the number of teeth divided by the dp. So since we're doing a 12 tooth gear, it's going to be 12 divided by 20 dp. Dp is like the diametrical pitch of the gear. And then you also want to add tolerance for your gears, because if you don't, then your gears are going to be like they're going to be too close together and they're going to like grind against each other. So you want to add like 0.003 of tolerance to each one. And then for the 64 tooth, it's the same thing. You would just do 64 divided by 20 plus your tolerance. And then you would use the tangent constraint here. So tangent just lets you make sure it's only touching at one point. So you would tangent the two gears together. And then you're gonna have to put mounting holes here for the motor, and then the bearing hole here for the thunder hex for the gear. So starting with the bearing hole. Bearing holes are 1.125 inches, and then you have to add tolerance for that for when it's being manufactured. So you would add 0.003 of tolerance. So, and then for the motor mounting holes, first for the bump in the middle, you would make a hole for that, and the bump is 0.75 inches in diameter, so you would just make this 0.8. And then the holes on a Kraken X60 are 1 inch from the center. and there are 1032 holes. So you would make these 0.196 for 1032, and then you would make it 1 inch from the center. And then, since Kraken X60s have, so you would need like all the mounting holes in a circle, so you can just do a circular pattern of that circle, and then you can just move it to the center of the Kraken X60, so it'll spin it all around it. And then you can change the number up here to be 6. And then you would do the outside of the plate. So there's going to be one plate for mounting the motor, and then there's going to be the gear, and then there's going to be another plate which like holds the gear in place. So you're going to need to CAD holes for the spacers that are going to, for the screws that are going to go through. Like how on this one you have this other plate that holds the gear in place. You need holes for these spacers that the screws are going to, the bolts are going to go through here and then into this plate. And this plate is going to have tapped holes, so you don't need a nut on this end, you can just put the bolt through. So to do that, we're just going to create a rectangle here, and then we're going to have our holes on the corners of these rectangles. And then our spacers are going to be 0.375 inches diameter thick. And then you can use the equal tool to just make all of these diameters equal. And then for the spacers, you can just dimension the last one. And then it does it for all, since you made them all equal. And then you can do that for the tapped hole as well. And then you can dimension this. So for 1032 tapped size, it's 0.159, I think. And then you just want to make sure that these spacers aren't going to hit the gear. So you're just going to dimension them to be like 0.1 inches away from the gear. And then you want to create like the outside of your plate. So you generally want to make your plates like as small as possible. You don't want any like excess material, because that like adds weight and it takes up more material. So you're just gonna have this tangented here, and then you're just gonna tangent these lines all around after you make them. So you just need your plate to contain the motor and then the spacers. So you're just gonna use it for that. And then you would just tangent it to the motor. And all the spacers. Okay. And then to finish off the plate, you would need to fill in all of these gaps. So to do that, you would use the arc tool, and the shortcut, keyboard shortcut for that is A. So you would just do it this, and then you would like bring it up here. And then you can use the co-indite constraint, and the keyboard shortcut for that is I. And then you can just do it that to this, and then it's like, yeah. And then you would just do that for all of these. So now that our plate is like shaded in gray, that means it's a complete plate. So then we can extrude it out. And since it's a new plate, we'd use new, and then since it's going to be a 1/4 inch plate, we would extrude it 0.25 inches. And then, very good. And then you want to name all your features. So here you would go and you would name it like mounting plate extrude, or motor plate extrude. Okay. And then we can also name this sketch to be motor plate sketch. Okay. And then we're going to create the second plate. So you can so you would create the sketch on the first plate. And then you would pull up your first sketch, and then you can hide your planes by clicking P, and then you can hide your first part here. We're going to do these as construction sketches. And the keyboard shortcut for that is Q. And then you're going to need these lines, so you would do that as not Q. And then you're going to need this bearing hole as well. Then you would just remake this line on top. And then you would tangent it again to the circles. And then you would do the same thing with the arcs on all of these. And then we have to make our holes for the bolts to go through. So these are not going to be tapped holes because, wait, what? Oh, okay. Okay, so these are not going to be tapped holes. These are going to be holes that the bolts are just going to go through. So and they're going to be 1032, so the size for that is 0.196. And then you would just do the same for all of these. Okay, so then that plate is now good, so we can extrude that. It's going to be another new plate, and then it's going to be 0.25 inches in depth. And then, since we created the sketch on the first plate, it'll originally start like on the first plate, but we want to offset it because the gear is going to go in the middle here. So we're going to offset it by like 0.75 inches for the gear to have enough room in the middle. And then this one is going to be called bearing plate extrude. And then we can rename this sketch. Okay. It'll originally start like on the first plate, but we want to offset it because the gear is going to go in the middle here. So we're going to offset it by like 0.75 inches for the gear to have enough room in the middle. And then this one is going to be called bearing plate extrude. And then we can rename this sketch. Okay. And then the last thing, okay, the next thing we're gonna CAD is the spacers. So to do this, really quickly, we can just look at our sketch for the bearing plate, since we CAD'd it in here with like a construction sketch. And then we can sketch on this plate. And then we can use the use tool again to just bring these to here. Make sure you don't click on the hole from the first plate and you click on the sketched hole, because this hole is a different size. So then then your spacer sketch is done, and you can name this. And then you can extrude it. It's a new part, and then it's going to be 0.75 inches because that's how much the plate is offset. But to make it easy, if you don't know the length, you can just, from blind, you can change it to up to face, and you can select the next part as your face, and then it will do it for you. So then you have to edit the appearance of each of the parts. So for this one, you're going to change it to be like gray since it's aluminum. And then for the spacer, you're going to make it, since it's 3D printed, it could be any color. So we're just going to make it like, we'll just make it like this black color. And then you have to assign the material for each part. So here for the aluminum, we use aluminum 6061. So you're gonna change it to aluminum 6061. And then for 3D printed parts, if it's PLA, you'll just make it PLA. But if it's onyx, that's not in the material library. So you're gonna make it, so instead of onyx, you would make it ABS, but this would be printed out of PLA, so you can just make it PLA. Okay. And then you just have to rename all the parts. So for the motor plate, so for each part, you would just go through and you would name each one. So this is spacer. And there you're good. Okay, and then you can move on to the assembly, or after you name this extrude. So this is the spacer extrude. Then you would create your assembly. So first thing, you would insert all your parts from your part studio. And then nothing is really like constrained right now, like you can move anything anywhere. So first thing, you want to create like your fixed part. So this motor plate, we're gonna mate it to the origin here, so then it can't move around. And then the keyboard shortcut for mate is M. So it's gonna be the origin here, and then you're gonna mate it to, like you would just click the outer ring of like the bearing hole, since that's like what it's around, and then you can just click good, and then now this won't move around. Okay, and then you can attach the spacer. So you would just mate the end of this circle to the end of this circle, and then you're good. And then, as you may have noticed, we only CAD'd one spacer when there's like 4 of them. So the easiest way to just, so we're just gonna, we don't wanna have to mate like the spacer 4 times, because that's like tedious. And in like a CAD where you have like 5 churros or something, you don't wanna have to mate every single churro, because that's just way too tedious. So we're gonna use the replicate feature. And basically you just click the part that you want multiple of, and then you click the face that it's like mated to, that you want to find more of like the same type of hole that it's gonna find, that it's gonna create another one in. So we would click this one because it's made it to that one, and then it sees that these other 3 holes are the exact same size. So it's gonna create 3 more of these spacers, and it's gonna put them on each of the holes. So we can click good, and then those are all mated together. And then we have to mate this plate to it. So we're gonna mate this plate to the spacer, and then we're good. Okay, so now we can start adding in all the motors, bearings, and gears. So we're gonna go to our FRC design inserter, or mkCAD, or whatever. And then first thing we're gonna do is our bearings. So it's a radial, it's flanged radial bearing, and then we're using the Thunderhex rounded bearing, and it's 1.125 inches. So we're gonna insert one of those. And then you're gonna click like you're gonna use mate, and you're gonna click like the edge here. And then you're gonna mate it to the edge of the plate. And then sometimes you have to like rotate like, or flip. So in this case we have to flip it so it's like properly in position. And then we're good. And then you're gonna right click on the bearing, and you're gonna you're gonna copy it, and then you can just hit like Control V or Command V, and then create a second one for the other plate, and then you can just make that one to it. Okay. And then, so we also, okay, I forgot to create like the Thunderhex that the gear is going to be on, but you would also just, you would go back to your part studio, and then you would use the shaft generator feature script, and then you would set the origin as like, so you would select this as the rim of the bearing hole as the origin, and then retention, we're going to use a bolt and a washer, and then it's a Thunderhex, and then we're going to make it like 3 inches, and then, okay, we're good. And then back to the assembly, we're going to have to reinsert it, so you would click the drop down of the part studio, and then you would find it here, click good. We forgot the most important part, to edit the appearance. Okay. So then you would mate the Thunderhex. You would use this edge and the edge of the Thunderhex. Okay, and then all that's left is the motor and the gears. So you're gonna go back to your inserter, and then you're gonna go to the motors, and we're using a Kraken X60, so we're just gonna insert one of those. And then while we're here, we might as well insert our gears. So our 2 gears were a 12-tooth pinion for the Kraken. A pinion is just a gear that would go on directly on a motor. So you can see here that the motor has like this spline shaft for Krakens. So we're gonna find the ones that are for spline, which is this one, and then we're using 12 tooth. So here, and then lastly the 64 tooth gear. So we're using a Thunderhex, so we would do 1/2 inch hex bore gear, and ours is 20 DP. And we buy most of our gears from WCP, so I'm just gonna insert WCP one. And then it's 64 tooth. And then since the 64 tooth gear is so big, we usually buy pocketed because it's lighter. Okay. So then those are the rest of our parts inserted. And then you would just go through and you would mate all your stuff together. So you would attach the motor, and then you would have to flip it in this case to make it be on the right side. And then next is the pinion onto the motor. And then here, since it's like not like fully on, you would just use the offset feature here, and then you can offset it by like an inch. That's a bit too less. You just do like 1.3, or that's too much. Do 1.2, just like 1.15. Okay. And then lastly, the 64 tooth gear. So we usually don't put like all the bolts and like that type of stuff into the CAD because it's really tedious and takes a while, and it takes up a lot of resources on like the computer. It's like a lot harder to load, so it's just like assumed that obviously like a bolt would go here to fasten it. So then this would be offset by like 2.7 inches maybe. Okay. So that was a bit too much. Let's do like 2.6. Okay. And then that's the final gearbox. So we're done. That was like really basic gearbox. So yeah.